These are our triangle congruence theorems. This video covers a little bit of section 4.2 as well as 4.3. These are the triangle congruence theorems. When we did section 4.1, we talked about the idea that in order for two triangles to be congruent, you need to have all 6 corresponding parts congruent. Well, today, what we are going to talk about is you may have some triangles where you know some things, but other things are left unknown. You can still determine that triangles are congruent. This first theorem is the side-side-side theorem, or SSS theorem, and pretty much what this theorem says is that if all the sides in one triangle are congruent to all the sides in another, then the two triangles are congruent. So when I look at these two pictures here, well, based on what we learned in section 4.1, we would have to say no, because none of the angles are marked congruent. But what this theorem is saying is that if you have a triangle and 3 corresponding sides are marked congruent, if you have a triangle that has this, you can automatically assume that the triangles are congruent based on the information that you're given. Even though no angles are marked in this picture, I can know for a fact that triangle ABC is congruent to triangle DFE, even though only 3 sides are marked. So if I know that the triangles are congruent because of side, 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 I can go into these pictures and I know that angle A since it is the first letter, has to be congruent to angle D. Angle B has to be congruent to angle F. And angle C has to be congruent to angle E. That's the side-side-side theorem. If you are given 3 sides and you know all 3 of those sides are congruent to the other ones, the whole entire triangles are congruent. The second theorem is called the side-angle-side. If 2 sides and the angle included within the sides are congruent, then the triangles are congruent. So again, what that means is if I'm trying to prove that 2 angles are congruent, if I'm given a side, an angle, and a side, I can assume that all corresponding parts of the triangle are congruent. Side, angle, side still looks like this. In this triangle right here, triangle ABC, notice this one has 1 little slash mark, and this side has 2 little slash marks. So this segment right here and this segment right here meet at angle A. So it's described as side, angle, side. Okay, same thing over here. The 2 sides that meet this is the angle marked congruent. So again, you have 1 here and 2 here, and those meet up right at angle E. So that's what it means up here when it says if 2 sides and the angle included with the sides are congruent to that of another triangle, like these two, then the triangles are congruent. So one thing you don't want to get confused on is when you have a triangle, you may have 2 sides marked, but then you have this one marked. This would not be side, angle, side. Let me show you an example. So in this example, we have 2 sides marked, but we do not have the angle marked that would be in between those 2 sides. We have this angle marked. So this would not be side, angle, side, even though we have 2 sides marked and 1 angle up here. So this example would not be side, angle, side. The next theorem is angle-side angle. This theorem describes if two angles and the included side are congruent to that of another triangle, then the triangles are congruent. So what that means is if in two triangles I have an angle marked congruent and another angle marked congruent, and the side in between the two angles is also marked congruent, this would be considered angle-side angle. Same thing down here. If I were to pick up this triangle and rotate it around, A would correspond with D. B would correspond with F. The side that is in between the two angles is the side that's marked congruent. So again, you have to pay attention to the order in which the stuff in the triangle is marked. If I happen to draw this triangle right here, so here's my triangle, and if I had this angle marked congruent and this angle marked congruent, and then all of a sudden I have this side over here, it's not enough to have one angle, one side, and one angle. You have to make sure that it's in this specific order. So this one has an angle and an angle marked, but the side that is included in the two angles is not marked, so you cannot use angle, side, angle. The last theorem is angle, angle, side, which states that if two angles and a non-included side are congruent to that of another triangle, then the triangles are congruent. So this is kind of like the one I showed you on the last slide. Notice I have two angles marked and one side. The reason why it's angle, angle, side is because the two angles that are marked are my two angles, and then the side that's marked congruent is not in between the two angles. So again, if I think back to my triangles on the other page, this was marked and this was marked. If it looks like this is angle, side, angle. The side is between the two angles. If it looks like this up here, this one is angle, angle, side. The two angles that are marked does not have the side included between the two marked angles. So that's why it's angle, angle, side versus angle, side, angle. These are the only four theorems that there are. Side, 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 angle, side, angle, side, angle, 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 side. Sometimes students might want to throw in an angle, 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 or angle, side, side, or side, side, angle. These are not theorems. So if you see these marked in a triangle, that does not mean that the whole entire triangles are congruent. So make sure when you are identifying theorems, you only use these four. And make sure you keep the letters in the exact order. So let's look at some practice ones here. This is asking, are these triangles congruent? So again, the way we can tell if the triangles are congruent or not is by looking at all 6 corresponding parts being marked congruent, or looking for the 4 theorems we just learned: side, 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 angle, side, angle, angle, side, or angle, side, angle. So in this picture right here, I have an angle and an angle marked. Then I have a side. So these are my 3 markings. You have an angle, and a side. This side is included between these two angles. Therefore, these are congruent because of the angle-side angle theorem. I am going to let you look at these two and see what you think. And we're going to move on to this next one. Now this one right here, I have two triangles and nothing is marked, but I'm given some information here. So like I was saying, nothing is marked, but with this information here, sometimes when you're given information, you may have to go into the picture and draw what it is saying. So it says ray DB is an angle bisector of angle D and angle B. So here's D, here's angle D, and here's angle B. If you remember, an angle bisector cuts the angles in half. So that means this one is congruent to this one. Okay, so this triangle and this triangle. So angle D is split into two. And angle B is also split into two. So what this gives me so far is an angle, angle, and an angle, angle. So my options for these triangles to be congruent, if you think back to those theorems, are either angle, side angle, or angle, angle, side. These are my options because these both have two angles in them. Now I've got to go back to look for a side that might identify if these are congruent or not. If you look at this ray right here, DB, ray DB is part of both of these triangles. Therefore, DB is congruent to itself. DB is part of the top triangle and it's part of the bottom triangle. So I can assume that it's congruent in both triangles. That's called angle, side, angle. So we're using for this one the angle, side, angle theorem. Now you can take a look at this last example on your own as well. Notice there is some information given even though you don't see markings in the triangles. So go ahead and see if you can come up with the answer to that.